So, once again, very warm welcome to your own educational channel. Today, we will discuss about the correlation between valency and group number of the element in the periodic table. Okay, after this topic, you will be get an exposure of periodic table. Okay, which is coming in your nearby higher classes. Okay, which you read about them in detail. So here you have to get a brief idea. So till now 118 elements are known to us. Okay, but you can see that our synthesizically 132 elements are there, but it is written earlier in the book. So 118 elements you can also understand, because only 92 elements are occur in earth, the rest are synthesized in the laboratory. So the arrangement of all elements in a tabular form is known as the periodic table. Okay, so you can see here the all elements, you can see in this periodic table all elements are arranged. Okay, these are arranged in a tabular form, in a table form. Okay, why we are giving them in a table? Okay, because it is convenient for all to understand about them. Okay, so if you see here in the periodic table, elements with similar chemical properties are grouped together. Okay, so you can see these vertical lines are known as groups. Okay, so if we are talking about that chemical properties of this group are same, okay, that's why they are kept in one first group. Okay, so similarly if you can take example any other, okay, so if they are represent one group, so they also find same chemical properties. So there are 7 rows and 18 columns in the periodic table. So if you count them, okay, there are 1 2 3 4 5 6 7 8. If you count till here, you will find 18 rows of groups, and there are 7 periods. Okay, like that, 1 2 3 4 5 6 7. Okay, these are 7 periods, and these are known as lanthanide and actinide series. Okay, which is come just after here. Okay, about them you will be reading in higher classes, but till here we have to understand just about the relation between valency and group number. So the rows are known as periods and the columns are known as groups. You understand that? Okay. These are groups. If you see here, these are the groups. Okay. And these are the periods. Okay. These are the periods. Yeah. Okay. And elements belong to a particular group have similar chemical properties, as we already discussed about it, and also exhibit the same valency also. Okay. So one example is there. Group first contain elements such as lithium, sodium and potassium. The valency of all these elements is 1. If you see, okay, this group, this is a one group, okay, and this is second group, first group, second group, okay. So if you see here, their valencies: hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, okay, till Fr, these are represented by first group and their valency also 1. Similarly, second group have the 2 valency. Okay, till now we have to understand these things. Now other things we have to understand: the valency of all these elements is 1 in first group. Okay, second group has 2, so the valency of all the elements is 2. Contains elements such as calcium, magnesium and beryllium. The valency of all these elements is 2. So elements present in group 13 exhibit a valency of 3. Okay, while those present in group 14 exhibit a valency of 4. Okay, so you have to understand that this group 13, okay, this group 13 have the valency 3 and it has 4. Okay, so elements 15, 16 and 17, okay, these groups 15, 16 and 17, they represent by 3 to 1 valency. Okay, elements 18 are inert columns such as helium and neon. They exhibit valency of 0. Okay, as you know that their outermost electron has 8 electrons, outermost shell has 8 electrons, they are completely filled, they do not react with any other elements. Okay, that's why they are called zero group elements or inert elements. Okay, so this is about the valencies.
So next thing we will read about radicals. Okay, so both atoms and molecules are neutral species, as you know. However, there are some species that carry either a positive or a negative charge. So these are known as radicals or ions. Okay, a radical is defined as a single atom of an element or a group of atoms of different elements carrying a positive or a negative charge. Okay, so the atom, okay, which carry a charge either positive or negative, or a group of atoms from different elements, okay, they can be combined and they also develop a positive or negative charge. So these are known as radicals, okay, or ions. The groups of atoms behaves as a single unit. So the radicals that are positively charged are known as basic radicals or cations. रेडिकल पॉजिटिवली चार्ज, इसमें मान लो Na है, ओके, इफ इट इज कैरी प्लस चार्ज सो इट इज एन basic radical or cation. These are generally formed by metals. Okay, so basic radicals or cations are formed by metals. The names of the basic radical are simply obtained by writing the word ion after the name of the metal from which they are formed. For example, a sodium atom forms sodium ion and has a net charge of +1 and is represented by Na plus. Okay, जैसे बताया Na है, ठीक है, इसमें अगर चार्ज आएगा तो Na प्लस हम लेंगे. चार्ज कैसा आएगा? जब इसमें से एक इलेक्ट्रॉन निकलेगा. ओके, one electron when it is removed, then it carry one charge. On the other hand, the radicals that are negatively charged are known as acid radicals or anions. Okay, anions, these are formed by non-metals. The name of acid radicals are obtained by changing the ending of names of non-metals from which they are formed to "ide", okay, and adding the word ion. For example, an oxygen atom formed oxide ion that has a net charge of -2 and represented as O2 minus. ओके, सिंपल है. जो मेटल से बनेगा उसमें तो सीधे आपने सोडियम है तो आयन जोड़ देना, सोडियम आयन हम कहेंगे, कैल्शियम होगा तो कैल्शियम आयन. लेकिन जो रेडिकल होगा एसिड वाला, ठीक है, एनायन वाला, उसमें आपको आईडी ही जोड़ना है. ओके, जैसे ऑक्सीजन O2 माइनस है, ठीक है, तो O2 माइनस हो रहा है, ठीक है, इट मीन्स इसमें कितने इलेक्ट्रॉन जोड़े हैं? 2 इलेक्ट्रॉन जोड़ रहे हैं, तभी इसमें 2 माइनस चार्ज आ रहा है ना, O2 माइनस. तो इसको हम आइट बोलते हैं, ऑक्साइड. ओके, ऑक्साइड आयन, ठीक है. ब्रोमीन में होगा तो ब्रोमाइड आयन, ऐसे ही Br माइनस होता है तो इसको हम ब्रोमाइड आयन बोलते हैं. ठीक है, आगे फर्दर नेक्स्ट क्लासेस में आप इनको और डिटेल में पढ़ेंगे. इसमें भी डिफरेंट डिफरेंट चेंजेस होते हैं जो हमने प्रीवियस क्लासेस में पढ़ लिया है. मोनो एटॉमिक आयन, ओके, एंड पॉली एटॉमिक आयन. मोनो एटॉमिक में देख लो, मोनो एटॉमिक में से सोडियम हो गया, ओके, Na प्लस, K प्लस, Cl माइनस, ओके, क्लोराइड आयन, ठीक है, और पोटेशियम आयन लिख दिया ये तो, ठीक है, हाइड्राइड आयन, ब्रोमाइड आयन एंड मेनी आयन, अदर आयन आल्सो, आयोडाइड आयन, I माइनस, ठीक है, जितने भी माइनस होगा उसमें Id जोड़ जाएगा. S2 माइनस है सल्फाइड आयन, N3 माइनस है तो नाइट्राइड आयन. ओके, इस तरह से आप लोगों को इसमें समझना है. ठीक है, Fe3 प्लस है तो फेरिक आयन, ओके, Fe3 प्लस और फेरिक आयन हो जाएगा. Mg+2 प्लस में हो जाएगा आपका मैग्नीशियम आयन. ठीक है, इस तरह से. और पॉली एटॉमिक में क्या होगा? 2 एलिमेंट्स के जो है आयन जुड़ेंगे. जैसे अमोनियम आयन अगर कहें तो NH4 प्लस, ठीक है, एक N है और एक H है, यहाँ पे समझना, ठीक है। NH3 और H जोड़ा है इसमें, ठीक है। अमोनिया और हाइड्रोजन जोड़ा है। ऐसे ही बाइकार्बोनेट आयन HCO3 माइनस, ठीक है। इसलिए हम इनको पॉलीएटॉमिक कह रहे हैं कि एक से ज़्यादा एटम से मिलकर बने हुए हैं, ओके। HCO3 बाइकार्बोनेट आयन, CO2 और H। ऐसे ही यहाँ पे हाइड्रोनियम आयन भी होता है, H3O प्लस, ओके। कार्बोनेट आयन CO3 2 माइनस कार्बोनेट आयन। नाइट्राइट आयन NO2 माइनस, NO2 माइनस नाइट्राइट, और NO3 माइनस मीन्स नाइट्राइड, ठीक है। इसको समझना, नाइट्रेट, ठीक है। ये हो जाएगा, अगर 3 है तो 8 टूटता है, ठीक है। अगर 2 है, कम वाली वैलेंसी में IT जुड़ेगा, ओके। ऐसे ही SO4 है, SO4, ओके, 2 माइनस, इट मीन्स सल्फेट आयन, ओके। PO4 3 minus, it means phosphate ion. So these all are polyatomic ions. तो यही था आपका रेडिकल्स और आयंस।
So I hope you understand about correlation between valency and the periodic table and about the radicals. Okay. For any confusion, you can contact anytime. Okay. Thank you.